In this video, we're going to review absolute value inequalities. So we've got this problem here on the board. You'll notice it just involves one variable, x. And we're asked to graph it twice. Once on the number line, treating it as just a one-dimensional problem, and then again in the xy plane, treating this as an inequality in two variables where y just doesn't happen to make an appearance. All right, with absolute value inequalities, same as with equations, I like to isolate the absolute value as my first step. So I'm going to first of all add over that 3, absolute value of x less than or equal to 8. All right, now because we were just adding a number, that didn't change the inequality at all. My boundary is what I get when I replace the inequality with an equal sign. So that would be the absolute value of x equals 8. And notice that's going to give me two numbers. X could be plus or minus 8. So if I'm graphing this on the number line, we can mark off negative 8 and 8. Those are two boundary points. They divide the number line up into 3 subintervals, and we've got to decide which one or which ones to shade. Now, because this was an inclusive inequality, those boundary points are included. So we can go ahead and put filled in points there. Now, as I said, there are 3 subintervals. What we can do is just pick a test number from each one to see whether we shade it or not. To the left of negative 8, let's try negative 9. If we plug that into the inequality, the absolute value of negative 9 would be 9. That is not less than or equal to 8, so we will not shade this portion. Between negative 8 and 8, let's choose 0. I'm going to just record here what we're choosing as our test numbers. If we choose 0, absolute value of 0 is 0. That is less than or equal to 8. So we will shade this middle bit right here. To the right of 8, let's choose 9. Absolute value of 9 is 9. That is not less than or equal to 8. So we will not shade this part. So this would be our solution set if we were graphing this on a number line. So that's our answer to part A. Want to just share another way that we could think about this. Here we went through one subinterval at a time and tested each one. That's certainly a viable option. But another way we could think about that is to remember that absolute value actually just means distance from 0. So this is saying that the distance that x is from 0 has to be less than or equal to 8. So we sort of marked off these two boundary points. 0 on our number line would be right there in the middle. Negative 8 is 8 units away to the left. Positive 8 is 8 units away to the right. Okay. So we can sort of think of this as if we're saying the absolute value is small, we're saying we want the distance to be small. As a general rule, I'm not super fond of children. But I have a niece and a nephew. Now, they're both in high school now, but when they were little, I was actually occasionally entrusted with their care. Okay. And I wanted to keep them safe. So I wouldn't let them go out and run in the street and play and get hit by cars. That would have been a bad thing. So when you're caring for children, you say, stay close. You sort of set some boundaries and you say, stay inside the boundaries. That's what a less than inequality does with absolute value. Keep the distance small, stay inside of the boundaries. Now, if this had been a greater than, that would describe my relationship with children that I am not entrusted with their care. If they are running around and screaming and making lots of noise, I just want to say, go away. keep your distance from me big. So if I have a greater than inequality, it would be, here are the boundaries. This is where I'm going to be. This is the safe zone. Annoying children belong far away on the outskirts. So you can certainly test the subintervals one at a time, but you can also just keep in mind absolute value less than a positive number means the distance is small. Absolute value bigger than a positive number means the distance is big. All right, and I said this had to be a positive number, of course, because absolute value is never going to be negative. All right, let's look at what this would look like in the xy plane. So now here's my two-dimensional plane. Now, the initial algebra that I would do is exactly the same. I would isolate the absolute value. I would say my boundary is what I get when I replace the inequality with an equal sign. The difference is, if x is plus or minus 8, instead of that being 2 points, that's now 2 lines, because x equals constant is a vertical line. So we would have a vertical line at negative 8, and we would have a vertical line at 8, and I should maybe write in here, these are going to be solid lines because we're including that boundary. So the axes here are not boundaries. In fact, let me just draw in these boundaries in red so that it becomes a little bit clearer. The axes are just my frame of reference. These are my boundaries. Notice they divide the plane up into 3 parts. There's the stuff to the left of negative 8. There's the region between negative 8 and 8. And there's the region to the right of 8. And we wanted to shade the places where the absolute value of x is less than or equal to 8. Again, this is the distance that x is from 0. X is 0 would be the y-axis. So we're talking about the distance to the y-axis. Well, if we want that to be small, we want to stay close to the y-axis. That's the region inside of those boundary lines. If you prefer, you could pick test numbers, 1 for each of the 3 regions. I think it's a little bit shorter and also helps me remember what absolute value means, to think small absolute value means stay close, stay inside the boundaries. All right, I'm going to have you folks try one. This is one from your homework. This is number 33. So doing this one, you'll be getting a jump start on your homework for this section. It's 2 times the absolute value of y is bigger than 2. And you are graphing that just in the xy plane. So for this problem, I reviewed it in the one-dimensional setting. For this problem, if you want to draw it on a number line first, you certainly can, but it's not necessary. You're graphing this in the xy plane, and we'll go over that at the next video.